Hello. Today we're going to be doing something really exciting. We're going to be looking at graphs of quadratic equations and identifying all the key features of the graphs, which in my opinion is really neat. So we're going to be using your graphing calculator and or Desmos.com to identify all these key features of your graph. Okay, so I do also have a printout of the graphs for you, so when you're looking back at your example problems, the answers that you wrote down make sense, because if you don't have a graph to look at, then you can't really understand what the answers to the different key features mean. Okay, so again, I do have these graphs for you to cut out and attach right next to your example problems, but I encourage you not to look at those so you can learn how to do and identify these key features on your calculator or Desmos.com, because sometimes you're not going to have the graph in front of you. You have to actually graph it yourself and find these key features. Okay, well, let's get started. So example 1 is the equation y equals 2x squared plus 3x plus 4. Okay, so I'm going to show you simultaneously, so at the same time, how to do this on your graphing calculator and Desmos.com. And again, you are allowed to use both of these options while you're taking your exam. So again, I encourage you to try both to see which one you like better. Okay, so on example 1 and 2, I really want you to try doing both at the same time. On example 3, probably by that point, you've kind of gotten familiar with the graphing calculator and Desmos, and you can kind of pick, well, I like doing the graphing calculator. So like on example 3, if you just want to do the graphing calculator, you can. Or if you prefer Desmos, you could do that one instead. So I will show you how to use both though. Okay, so at this time, please make sure you pull out your graphing calculator. You also need to, on your Chromebook, type in Desmos.com. So Desmos.com. Okay, and when you click on Desmos.com, don't forget, it'll take you to a screen that looks like this. Okay, and then when you get there, you click Start Graphing. Okay, so again, I know that you're watching this video. What you can do is like kind of minimize the video screen, and then on the other part of your computer, you can pull up Desmos.com so you can kind of practice doing it as you watch the video. Otherwise, you're not going to be able to practice it on Desmos. So you can have your graphing calculator up. That's really easy to do. But Desmos.com, you'll need to minimize your video screen so then you can see Desmos.com. All right, you guys. Well, hopefully your graphing calculator's out and we can get started identifying these key features. Okay, so I'm going to turn mine on. Okay, make sure you guys, so we are going to be graphing. So make sure anytime that you're graphing on your graphing calculator, what you need to click on is y equals. So click on y equals. Okay? On Desmos.com, we'll be typing in the equation to this bar right here. But I'm going to start with the graphing calculator. Okay, so the very first thing that we need to identify are the x-intercepts of the graph. Okay, so here's your graph, you guys. Again, try not to look at it, but I will be like labeling things on the graph. So this is what the graph is going to look like. I know I ruined the surprise. Sorry, you guys. Anyway, so we're going to identify these key features about the graph, but we're going to practice this using your graphing calculator. Okay, well, let's get started. So the first thing we're going to find are the x-intercepts. So that is where the graph intersects or smacks the x-axis. So let's see where this graph hits the x-axis. Okay, so I'm going to type in my equation. So it's 2x squared. So I got a 2. Remember, when you type in a variable, you click on this this button that has like x and t, and that symbol right there is theta. Okay, this symbol means variable. So even if your variable is not x, okay, if your variable is like y or r or t, you can still use this. It'll just appear on your graphing calculator as an x. Okay, the squared button's right here, this little x squared button. Okay, then plus 3x, so 3, I'm going to hit the x button, and then plus 4. And I'm going to hit graph. So you can hit graph. A good thing to do, you guys, if you ever want like a 10 by 10 window, so where your x-axis goes like from -10 to 10 and your y-axis goes from -10 to 10, the way that you get that every single time is you hit zoom and then you hit 6 for standard. So you can either hit the 6 button or you can like scroll down and hit enter when you're over the 6. It's up to you. So whatever you want to do, give you this nice window. Okay, so the x-intercept is where the graph hits the x-axis, which if you guys see here, the graph never hits the x-axis. So unfortunately, I can't use my calculator to find them because we don't have any. And remember, you guys, do you remember what kinds of zeros you have if you don't have any on this real number system graph? Holy hot dog, they are imaginary or complex zeros. So I do know that my x-intercepts are imaginary or complex because I can't see them. Okay, so again, at the same time, I'm going to show you how to do this on Desmos. So the way that you type in your equation on Desmos, you click on one of these boxes, and I'm just going to type in the equation using my keyboard. So I'm going to type y equals 2x. The way that you get the squared button, you can hit Shift 6. It'll take you to the exponent and you can hit squared. Or if you click this little keyboard button down here, you can click the little squared button there. Okay, or if you click this A to the B button, it'll push the cursor into the exponent. So you have several options. Now, when you're in the exponent, how you get out of the exponent is by either clicking off like this. Okay, or if you click the right arrow, it will get out of the exponent. Okay, because otherwise you're going to stay in the exponent. See, so just be careful and don't type all that. Okay, so 2x squared plus 3x, so plus 3x, and then plus 4. So if you see, I have the same graph, it's just now in Desmos. And again, I don't have any x-intercepts, which is really sad. So on mine, again, we don't have any x-intercepts because it doesn't cross the x-axis. So I'm going to write none and a sad face because we don't have any. And remember, if we don't have any, this means that the zeros are, you can say like imaginary or complex. So that means they're there. We just can't see them because this is a real number system graph. Okay, well, the next thing that we need to identify is the y-intercept. So I'm going to go back to your calculator. All right, now, your key button on your calculator when you're graphing and finding things on your graph is the second trace button. Second trace is going to be your best friend when you find all these nifty key features. Okay, so the way that we find the y-intercept, or where the graph hits the y-axis, I'm going to hit second trace. Okay, now, there's not a y-intercept button on your graphing calculator. We kind of have to do a roundabout method to get there. Okay, so what we're going to do is this value button. What the value button does is you can type in any x value you want, and it'll tell you what the y value is on the graph. All right, so I'm going to click value, so you can either click 1 or hit enter when you're hovering over the 1, which I currently am, so that's good. So I'm going to hit enter or 1, doesn't matter. So do you guys remember what the x value is when you have a y-intercept? What is x always going to be on the y-axis? Well, remember we have the points like 0, 1, 0, 2, 0, 3, 0, negative 523. Okay, so what is x always when we're on the y-axis? X is always 0. So to get your y-intercept, we want to know what y is when x is 0. Okay, and with this feature, you can type in any x value, and it'll tell you what the y value is on your graph. So I want to know what y is when x is 0. So I'm going to hit enter, and it tells me that y is 4 when x is 0. So I know my y-intercept is at the point 0, 4. Okay, now in Desmos, in my opinion, is easier because if you guys remember, okay. When you first type it in on Desmos, it already highlights the key points on your graph, which if you notice, one of the key points it's already highlighting is the y-intercept. So on Desmos, to find anything, you just click. So I want to know what this point is, so I click. It's at 0, 4. All right, so again, in my opinion, Desmos is easier, but it's not wrong to use your graphing calculator. Okay, so our y-intercept, I'm going to go back to here. Our y-intercept is right here. So this is our y-intercept. Okay, and it's at the point 0, 4. Or you can also say where y equals 4. There we go. All right. So our next question is, what is the minimum or maximum point? Which Quadratic equations either have just the minimum or just maximum. They can't have both. Okay, so one of these, we won't have one. Okay, so let's go back to the graph. Gonna go to the calculator. Okay, so if we're looking here, it appears, what does it look like? Does this graph have a maximum or a minimum? Well, it definitely has a minimum. Nice job, you guys. And another way to know, since your A value is positive, it's a happy graph, which means you have a minimum because A is positive too. Okay, so we have a minimum, so I don't have a maximum, but I want to know what is that point. So again, the key button that you're going to be clicking on your calculator is second trace. I'm going to go to second trace. I want to know this time I have a minimum, so I'm going to scroll down to minimum and either hit enter or you can just type 3, whatever you want to do. Okay, so remember to do this, we're going to find the left bound, so I need to scroll to the left of my minimum. So how I do that, I'm going to hit the way that you move this little spider guy, I call it a spider guy, you either click the left arrow or the right arrow. Okay, so I'm going to click the left arrow to move it to the left. So when you're to the left of your minimum, you hit enter. Then it wants to know the right bound. So you want to be to the right of your minimum. So I'm going to hit my right arrow key until my little spider guy is to the right. All right, it's to the right. So I hit enter. And then when your calculator asks you to guess, you hit enter. So my minimum is at the point negative 0.75 and then 2875. All right, which I'm going to go ahead and write that down on my paper before I forget. So our minimum is at the point negative 0.75 and then 2.875. Okay, so that's how you find that on your calculator. Again, on Desmos, when you type it in, it already has it. Oh, geez, Louise was long. It already has it highlighted for you. So you just click it, and there you go. So I found the minimum on Desmos. We're good to go. All right, so that's how you do it on both options. Okay, so this is our minimum right here. So this point is the minimum. Okay, and it's at the point negative 0.75 to 0.875. Okay, so since this one has a minimum, that means it doesn't have a maximum, so we don't have one. So you can write like none or n/a doesn't apply, any of those. All right, now, this is a new concept that I need to teach you, which you might have learned this in a previous math class, but probably not with this notation. So we need to go over that. Okay, so the end behavior. Where do you guys think are the ends of a graph? Well, they are at the arrows. We want to know, well, where is the graph headed to? Which basically means, well, where are the arrows pointing? Okay, so in behavior, this notation means as x heads to negative infinity, okay, that little arrow means as it approaches or as it heads. Okay, remember, mathematicians are lazy, so we tend to use a lot of symbols, okay? So as x approaches negative infinity, okay, so if we're looking at the x-axis, which side of your x-axis is the negative side of the x-axis? Well, that is the left side. Okay, so this basically means when you are on the left side of the graph, what we want to know is what f of x is approaching, which remember, f of x is the same as y, so this could technically say y. So I want to know on the left side of the graph, what is y doing? Where is y headed, or f of x? Okay, which if you guys notice, the y-axis either heads up or down. So basically what you're asking is on the left side of your graph, where's your arrow pointing? Is it pointing up or down? Okay, well, if I look on the left side of my graph, my arrow is pointing up. Okay, so on the left side of my graph, the arrow is pointing up. Okay, and if we're heading up, is that a positive or negative direction on the y-axis? Well, if you go up on the y-axis, you're heading in a more positive direction. So when we're on the left side of the graph, the arrow is pointing up, which means it's headed to positive infinity, a positive direction of infinity. So again, this means up. Okay, so then this says as x approaches positive infinity, or when we're on the right side of the graph, Okay, so the right side of the x-axis is where we're headed to positive numbers, okay? So as x approaches positive infinity, as we're headed in a positive direction, we want to know where is the y value headed, okay? Or basically, where's your arrow pointing? Okay, so this basically means as x approaches positive infinity, on the right side of your graph, where's the arrow pointing? Is it pointing up or down? Well, on the right side of the graph, it's pointing up. And if you're headed up, are you headed in a positive or negative direction on the y-axis? We're headed in a positive direction. Okay, so this means f of x is headed in a positive direction, y is headed up. Okay, so this simply means up. Okay, so when you guys are doing in behavior, okay, this is how it's always going to look. You will always have this listed. You always want to know what the graph is doing on the left and right-hand side. So this part will always be in your end behavior. You're always going to have, well, when x approaches negative infinity and when x approaches positive infinity. What you have to fill in is where your graph is headed on the left or right side, which if it's pointing up, it's headed in a positive direction, so it's positive infinity. If the arrows are pointing down, okay, if you're headed down on the y-axis, is that a positive or negative direction? Well, that is a negative direction, so that would be negative infinity. Okay, so when you have a parabola, these will either both be pointing up or both pointing down, because on parabolas, both arrows either always point up or both point down. So these are either going to be both positive infinity because they're pointing up, or both negative infinity because they're both pointing down. Okay, which you could, I know that I told you not to look at this, okay, but you can see that on your Desmos graph or your calculator as well. So, oh, my calculator's turned off. Rude. All right, let's see here. Okay, so both arrows are pointing up on the left and right-hand side of the graph. So there you go. Okay, the next thing we're going to be identifying is the interval of increase and decrease, which this is a little tricky. Okay, so when you guys are determining where the graph is increasing or decreasing, you must trace the graph going from left to right. Okay, which I'm going to clear this real quickly. Okay, so when I go from left to right, that is how you know if you're going down or up, or increasing or decreasing. Guys, so if you're headed downward, do you think you're increasing or decreasing? Well, if you're heading downward, you're decreasing. If you're heading upward, you're increasing. Okay, now, if you guys notice which point on your graph is where the graph will change directions. What point have we talked about that makes sense where the graph goes or changes from a decrease back to the increase? What point on your graph is the point where it kind of changes from that increase to a decrease? What do you guys think? Holy hot dog. It would be at either the maximum or minimum. Okay, so this is going to be based on kind of where your maximum or minimum point is. And when I ask you for intervals of increase or decrease, what I'm asking you is, what are the x values on your graph that make the graph either increase or decrease? So it's a little confusing because when we look at an increase or a decrease, we kind of think about y, because y is what causes the graph to go down or up. Okay, well, this is actually asking you what x values make the graph decrease, which x values make the graph increase. Okay, so we're thinking about x values, not y values, so just be very careful. Okay, so you need to have your minimum point back on here in order to determine your intervals of increase or decrease. So I'm going to get the minimum point back up there, so I'm going to hit second trace, minimum, so I'm going to click 3. Okay, I need to scroll to the left because I'm left bound. I need to hit enter. I need to scroll to the right of my minimum because it's asking for right bound. Hit enter. And then when it asks me to guess, I hit enter. Okay, so this is our minimum point. Also on here, you can just click and it'll tell you. Okay, so either way. Okay, so again, I want to know which x values make the graph increase or decrease. Okay, which when we go from left to right, the first thing the graph is doing, what do you guys think? Is it starting out increasing or decreasing right now? Absolutely, you guys, it is decreasing. Okay, so I'm going to start with the interval of decrease. And again, you guys, this is about the x value. So I'm going to look at the x value on your minimum. Okay, so it's all about where it is in relation to the x value on your minimum. Okay, so I want to know what I'm going to do, which unfortunately, this is where your graphing calculator is kind of limited. You won't be able to do this on your graphing calculator. So I'm going to show you how to do this on Desmos. Okay, it's all about that minimum point, you guys. Okay, so I want to know, are they the x values to the left or to the right of that minimum point that makes my graph increase or decrease? Okay, so I'm going to kind of I'm going to do a dashed line real quickly. Okay, so we know the minimum x value is at negative 0.75. So I'm going to draw a vertical line, which again, you can't do this on your graphing calculator, so that's why your graphing calculator is kind of limited. So I'm going to type x equals negative 0.75. Okay, and that will give us like the dividing line. Okay, to the left of this line is where the graph is decreasing. What do you guys think about to the right of the graph? Is that where it's increasing or decreasing? Well, that is where it's increasing. Okay, so let's focus on the decrease for right now. Okay, if I'm to the left of the graph, are these values to the left of this line larger or smaller? Are they getting larger or smaller? Are they larger or smaller than negative 0.75? What do you guys think? Well, the numbers on the x-axis that are to the left of this point are smaller than negative 0.75. They are less than that value. Okay, so if I say x is less than negative 0.75, if you guys see here, this is the section of the graph where the graph is decreasing. Okay, so the interval, I want to know every single x that makes this thing decrease. So the interval where this graph is decreasing is where x is less than negative 0.75. Okay, which I know is kind of confusing because we're thinking about x's, not y's. Okay, so we have to be careful. Okay, so again, I'm going to draw that on here. Sorry, my voice. I'm going to draw that on here. Here's like my dividing line. Okay, this is where the graph is decreasing right here. So it's decreasing right here. I'm going to abbreviate decreasing. Okay, you can write it out if you want. But anyways, the interval that it's decreasing is all the values to the left. So all these values on the x-axis. Okay, this is causing my graph to decrease. These are the values that make the graph decrease. Okay, so my intervals of decrease is where x is less than negative 0.75. And again, it's all about what is the x value in your minimum or maximum point. Okay, now we're going to do the same thing with the interval of increase. Okay, so again, I'm going to show on Desmos because unfortunately your graphing calculator can't do these things. So, but anyways, so I want to know now where the graph is increasing. So I'm going to stop that. Okay, so the graph is increasing to the right of my dividing line. So this is my division line. It's kind of mean. But anyway, so I have my dividing line. To the right of this line is where the graph is increasing. So if I go to the right of the line, are these values larger or smaller than that negative 0.75? Are things like 2, 4, 6, 8, are they larger or smaller than negative 0.75? Well, they are larger. Okay, which if you guys see, if I type x is greater than negative 0.75, whoa, do you guys see? It shades in only the part of the graph that is increasing. Okay, so my interval of increase is where x is greater than negative 0.75 because these are the x values that make the graph head upward or increase. Okay, so on here, again, this is where I'm going to be increasing, okay, which I'm going to do in a different color. On this part of the graph, this is where the graph is increasing. Oh, sorry, I have tape on my paper, so it's not letting me write it. So these are the x values that make the graph increase. Okay, so the intervals that increase, when we're to the right of this line, we're going to be greater than the values. When we're to the left of this line, we're going to be less than. So this is where x is greater than negative 0.75. Okay, which this concept I know is a little tricky, but the more we do it, I promise, the more it'll make sense. Okay, well, the last step is the domain and range. Okay, so again, you can either look at this on your Desmos, or your calculator. If my calculator would stop turning off, rude. But anyways, okay. So, your domain and range. We need to know the minimum point again to do this. So, your range, your domain. Domain is asking you, what are all the x values allowed on this graph, or which x values work on this graph? Okay, and if you guys notice, the x-axis goes from the left and the right. Okay, it heads to the left, it heads to the right. So you're asking yourself, how far left and right does your graph go? Which you can look at either of these. Okay, well, it doesn't look like it, but if you keep zooming out, which on here, if you click this negative button, you zoom out. Click the positive, you zoom in. Also on here, if you guys click the home button, it'll take you back to the 10 by 10. On your graphing calculator, how you zoom in and out, you click the zoom button, zoom. Okay, if you want to zoom in, you click 2. And so if you want, I'm going to zoom out. So if you want to zoom out, you hit 3. And then you just kind of where you want to zoom out, you move your cursor and you hit enter. Okay, and it'll zoom you out. Okay, but again, if you want to go back to your 10 by 10 screen, you hit zoom 6 for zoom standard. All right, now, it does not look like it, but I pinky promise you guys, which is the most serious kind of promise. Okay, what will happen on your graph? It's going to continue to get wider and wider on your graph. Okay, so on your graph, this thing will keep getting wider and wider. So if it keeps getting wider and wider, how far left and right do you guys think your graph will go? Well, it's going to continually get wider and wider, which means it's going to keep going left and right for forever. Okay, so that means when you have a parabola, every single x value will work because the graph is going to head to the left and to the right for forever. Okay, so all of the real numbers on this graph will work for the x values. Okay, so what we're going to say for the domain, we're going to use some nifty symbols because, again, mathematicians are lazy and we use these crazy symbols. But anyways, the way that we say that all the x values are being used is we say x is all real numbers. X is all real. Okay, and the way that we write that, it's kind of cool. You write an x. Okay, then you're going to draw this little C thing. And you're going to draw a little line through the C. So it kind of looks like a weird E looking thing. So that means x is, or x such that, that's what that symbol means. And how you say all real numbers, the symbol for all real numbers is kind of a weird looking R. So you're going to draw 2 vertical lines. And then you're just going to draw an R over it. So I'm just going to draw an R, like that. Okay, so what this means is x is all real numbers. Okay, so instead of having to write that out, because we're lazy mathematicians, right? You can just write x is all real. Okay, and every single parabola that we do will continue to get wider and wider. Okay, so that means we're going to head to the left and right for forever, which means we'll be using all the x values no matter what. So every single time we do the domain and range, when you have a parabola, this will always be your domain. So my domain is always x is all real. Okay, so again, that's when you ask yourself how far left and how far right does your graph go? Well, the range deals with the y values of the graph. So the y-axis goes up and down. Okay, so this is when you ask yourself how high does the graph go and how low does the graph go? Okay, so if you guys see here, how low does our graph go? Which I'm going to look at this graph because it's a little trickier. Okay, which remember, you need to know your minimum. So on your calculator, you need to have your minimum pulled up. I keep undoing that. So if you want to pull up your minimum, again, second trace, minimum is 3. Scroll left, enter. Scroll right, enter. And then enter. Okay, and then on here, I just click. It's easy. Okay, so what is the lowest? And I'm going to hide this. If you want to hide a graph on here, you just click this button. All right, so the lowest point on this graph, how low does it go? What is your lowest y value? Well, that would be the y value of your minimum. So how low does your graph go? Well, the lowest y value is 2.875. So that's how low the graph goes. Then how high does the graph go? Well, the arrows at the top means it's going to head to infinity, which if you guys didn't know, Buzz Lightyear hangs out at infinity, which is really cool. So the graph is going to head to infinity and beyond because it's going to keep heading upward for forever. Okay, so are the values up here, are they larger or smaller than the 2.875? Well, numbers like 4, 6, they are larger than 2.875. So these values are larger or greater than 2.875. So the way that we're going to write our domain, our range, is we're going to say y is greater than. Now, technically the graph does equal this point because the point is shaded in. Okay? So it's greater than or equal to, let's see here, the y value this time, which is 2.875. All right, so our range, it's equal to this point, and it's going to be everything larger than this point, because all these points up here are larger than the 2.875. Okay, so that's how we're going to find our key features. Again, I encourage you to try both your graphing calculator and Desmos.com when we do this on example 2. And then on example 3, you guys get to pick what method you prefer. All right? Well, that was fun, you guys. Let's get started on the next example problem.